Hey guys, I'm uploading a video on YouTube. This video is about me to solve a physics problem. It's about electric field. This is the problem right here. So on the XY plane, you will have three charged particles. Q1 at negative d00 with magnitude with charge E. Q2 is 3e, and this is its location, 1.91 d00, and Q3 is negative d2d0 with the charge negative 2e. So the first question, they ask you to draw the E field for each of them, and the second question is draw the E net of all of them. So for the E1, because it's positive, so the electric field is going to go away from the charge. So it's going to the right, which is I mark E1 right here. And for Q2 is also positive, so the electric field is going to go to the left, away from Q2, which is it going to the left. Yeah, so I mark Q2 right here. And for Q3, because it's negative charge, so it's going to go towards the charge. The electric field is going to go towards the charge, so it goes this way. So the net, so now next time we will find the net E field for 1 and 2, because the magnitude of Q2 is bigger than the magnitude of Q1. So the net E1 and 2 would go to the left this way, and I'm marking this E1, 2. And from E1 and 2, we will add to E3 to find the net electric field for 3 of them, which is the red vector right here. So we just add them, and you got this vector right here, which is the E net for 3 of them. So for question number 3, it tells you to find the Q4, the charge is negative E. So where Q4 should be positioned such that E net at the origin is 0. So what we need to do is find the electric field for 3 of them, and then add them together, and from there we find Q4, which is equals magnitude but opposite direction. Okay, so for Q1 right here, the observation location is 0, and the source location, observation location is our origin, and the source is negative d00. So the relative vector would be observation location minus the source, so that would be d 0, 0, and the magnitude of r would be d squared, that would be d in square root, and the r hat would be 1 over d times d 0, 0, that would be 1, 0, 0. Okay, so the electric field, we would use the formula for the particle charge. So the E1 equals 1 over 4 pi epsilon naught times Q over R magnitude R squared times R hat, which is, this value right here is 9 times 10 to the 9. I hope you guys know that. I hope you know that. And for Q, that will be E, so 1.6 times 10 to negative 19, and R squared, which is D squared, and R hat, which is 1, 0, 0. So, because I already have the answer here, and the answer for this, so E1 would be 1.44 times 10 to negative 9 over D squared, 1, 0, 0. So this is our D1 right here. And we have to find D2. We do the same thing. So the observation location is 0 at origin 0, and the source will be 1.91 d 0, 0. Okay, and the relative vector would be take the observation minus the source. So this one actually turned out to be negative. So that would be negative 191 d 0, 0. And the r, the magnitude of r would be square root of 191 d square plus 0. I don't have to write it out. And so it will be 191 d, and the r hat would be 1 over 191 d times negative 191 d 0, 0. That will be negative 1, 0, 0. The E2, and we use the same formula of the part of a point charge. That will be 1 over 4 pi epsilon naught times q over r magnitude 1 square times r hat. That will be 9 times 10 to the 9. This is 3 times 1.6 times 10 to negative 19 times divided by 1.91 d total square. Yeah, and times with the r hat, which is negative 1, 0, 0. And sorry, so I have here, so E2 will be 1.184 times 10 to negative 9 over d squared times negative 1, 0, 0. Okay, so this is R2. And now R3, we do the same thing, but I will erase there's those questions right here. No, I'll do it here. Okay, when I don't have space, I'll erase it. So R3, sorry, electric field at position 3. So that will be the observation location is the origin, and the location of R3 is, so the source is negative d 2d 0, and because the observation location is our origin, so